in this lesson, we're going to talk about absolute value function. Before we talk about absolute value function, we're going to talk about what is absolute value. Absolute value. Okay, absolute value is the distance between any number from origin. Okay, the distance between any number to origin. For example, when we look at the number line, okay, there is a spot, right? We call the point of reference, And we call this number 0, right? That's the origin. This is the so-called origin. Any number, right, has a place. Any real number has a place on this number line. And that number, suppose that, for example, if we have, say number 5, right? Suppose I have 5 right here. The distance between 5 and 0, right? We can say the distance between 5 and 0, right, is 5. Because all we have to do is to measure how many units between 0 and 5. So the distance between 0 and 5 is 5. But the distance between one number and the origin, this part, okay, this part alone, we're going to use a shorthand notation. And that shorthand notation is absolute value of 5. So this notation represents the entire phrase. Is 5. Okay, equals to 5. Okay, another example. Suppose we have another number, which is -3. Okay, -3. Then the distance between -3 and 0 is, right? All we have to do is just count how many units is between -3 and the origin. There are 3 units. There's 3 units is 3. So we just care about how many units between these two numbers. We don't care about the direction, right? We don't care whether it's on the left-hand side of 0 or on the right-hand side of the 0. And so this entire phrase, okay, is shorthand notation. Shorthand notation is written as -3 in between 2 vertical lines, and that is 3. Okay. Now, what's the distance between 0? What's the distance between 0 and 0, right? 0 is the origin. Well, that's 0, obviously, right? So shorthand notation we use here would be the absolute value sign. Okay, so we use this absolute value sign. And this absolute value sign means the distance between whatever number to the origin. The absolute value of 0 then is 0. So that's the notation, right? That's the notation. So first we understand the notation is really just a, a shorthand notation. It represents the distance between the number and origin, the distance between a negative number to origin, so the distance between a positive number to origin. So it's always relative to the same point, 0. Okay, so as we can see, the absolute value of any number is either 0 or positive, right? Distance is always positive or 0. Okay, you cannot say distance is always positive because it can be 0. It can be 0. Okay, so with that understood, and then we know the we can also say the distance, right? Another word to say it, there's a distance. Distance is always non-negative. Okay, always non-negative. Or you can also say the distance is always at least 0. So all these are different ways we can say it. And mathematically, right, how do we express distance, right? So suppose x is any real number, right? X is any real number. The distance between this number, which is absolute value of x, the distance between this number and the origin is going to be at least 0. So all of these three sentences, right? Mathematically, we can write it as the absolute value of any real number, right? We can say for any real number, x. So that's what we have realized. That's what we have realized. Okay, so now we can talk about the absolute value function. Now we can talk about the absolute value function. Now we have realized the absolute value of positive number is the same as number. The absolute value of negative number is its opposite, right? The absolute value of 0 is 0, and absolute value of any real number is at least 0. So using absolute value function, using absolute value as a rule, okay? So we're going to create a function. This function is called absolute value function. So this function is defined as the absolute value of a number. Okay, so let's look at how this rule works, right? So for absolute value function, of course, right, we know it's a rule that assigns to each element x from a set of A exactly one element from, called f of x in the set of B. So we're going to identify domain, range, and the graph. Domain, range, and graph. All right, so this rule, right, so we have input. Input is given to this function, right? It produces an output. And that output is f of x equals to absolute value x, absolute value of x. So that's the rule. That's the rule. Take some examples, right? Take some examples. If our input is -3, then the rule applies to -3. Then we get a -3 in absolute value. The absolute value of -3 is a +3. Which is the opposite of -3. And the absolute value of 0, f of 0, the absolute value of 0 is 0. And the absolute value of 2, the input is 2. Absolute value of 2 is 2. It's the same as the input. So you can see sometimes if you have a negative input, negative number as the input, the output is the opposite of the input. The absolute value of 0 is going to be the same as the output is going to be the same as the input. If the input is a positive number, the output will be the same. So in these two cases, right, you can well try a lot of other examples. So what do we have discovered? We have discovered something, right? It seems that we have discovered something. What have we discovered? Right? If the input is negative, okay? If the input is negative, if x is negative, well, let's start with positive, okay? If x is positive, the absolute value of x is the same as x. If the input is 0, then the absolute value of x is 0. If the input is negative, the absolute value of x is going to be the opposite of x. Does that make sense? All right. Well, let me make a few sentences about what this explains. Okay. This first sentence. Okay. This first sentence. What does that mean? I'm going to write down the words. Okay. I know some of you might have a hard time with it, but it's very important to understand this. It's very important to understand this. Okay. So the absolute value, right? The absolute value from what we have done. Okay. The absolute value of a positive number is the same as the number. The absolute value of 0 is the same as 0. And the last, the absolute value of a negative number is its opposite. Okay, it's refer to a negative number right here. Okay, now if you have a hard time understanding this, you may like to pause the video and think about it. Okay, in the case of positive input, we get the same output. In the case of 0, we get 0. In the case of -3 as input, the output is going to be 3. 3 is the opposite of a -3. Is it always the case? Of course, if this is a -5 and the input is a -5, and this is going to be 5. 5 is opposite of -5. So it's always true. So the last sentence oftentimes is the most difficult to understand. Now, we're going to combine these two because these two sentences, okay, these two sentences can be combined, right? The absolute value of positive number and the absolute value of 0. So if we combine these two, we can say the absolute value of a non-negative number is the same as the number. And the last sentence, the absolute value of a negative number is its opposite. Okay, so now compared with the form that we did earlier, right? These two can be combined. Yes. So when we combine these two, what do we get? We can say if the input is greater than or equal to 0, and the absolute value is the same as the number. So these two is combined into 1. So now we have these two, right? So now let's organize our work. Okay, removing that. So this piece summarize, that's a summary for that. Shorthand notation, and that piece is to say that. So you can see these two sentences, make sure you understand it, okay? And the next sentence, okay, if the absolute value of a negative number. This piece is a little difficult to understand. So let me explain this, okay? With the examples we did before, okay, I'm gonna bring back the examples here. Okay, so let's look at some examples to see if this works, right? Does it work, right? -5, right? The absolute value of -5 is 5. So now if x is less than 0, right? So I'm going to choose a number x is less than, so say x equals -2.5. According to this statement, when x equals to -2.5, we're going to replace x by -2.5. And this x will be replaced by -2.5. And negative or -2.5 equals to 2.5. It works. So in the end, we do get the absolute value of -2.5 is equals to 2.5. So that works, okay? Feel free to try a few more examples. Try your own examples. So you may like to pause here. So the absolute value of a non-negative number, the absolute value of negative number. So we got the two of these, right? For negative, for positive. For positive and for negative. This is for non-negative, right? That's for non-negative. How do we combine this mathematically? In mathematics, we combine them this way, okay? First of all, I'm going to switch. Okay, so I'm going to put an if behind. Okay, maybe lowercase I. And I'm going to switch if. That's okay, right? It works grammar-wise. Okay. Now there's a repetitive part, here. So in mathematics, at the entry of when you enter in your calculus class, what you're going to see is the following. Okay, you're going to see two branches. You're going to see two branches. Just like that. Okay. Absolute value is the common part. So absolute value equal to is a common part. And there are two branches. One goes here. And the other one goes here. And you guessed it. So if x is greater than or equal to 0, the absolute value of x is the same as the number. The absolute value of a negative number, which is on this branch, is going to be its opposite. Okay, so this is the function. So this function, absolute value function, right, as we know it, can also be written, right? Can also be written. This is the function, this rule of the function, it can also be written in this way. Okay, so let's look at domain and range. Domain. Can we find absolute value for any real number? Yes. So the domain is going to be all real numbers. How about range? We actually mentioned the range earlier, right? The absolute value, as we know of, is never going to be less than 0. It's always going to be at least 0. We already mentioned that. Okay, we already mentioned that. So the range, domain range in one sentence. So this is actually the domain range in one sentence. The range alone, we can use just the absolute value greater than or equal to 0. Domain range in one sentence. Right here. Domain range, this is very, very useful. Extremely useful. Okay. So now we got a domain, we got the range. How about the graph? How about a graph? Right, input, output. Okay, input, output. So we're going to make a table. Okay, make a table. Input, output. Points made of input, output. Okay, so what are the points? We're going to choose some positive number, we're going to choose some negative number, we're going to choose some 0, right? You can say -3, -2, -1, 0, 1, 2. If you like, we can do 3, but we don't have to, right? So let's you know, just to have a little 1 more points, right? The input, output. How do we get the input, output? You see, we can use this expression, right? We can use this expression, the output. When input is -3, -3, see how we use this function, right? When input is -3, so we're going to go with this branch. Okay, so we're going to write it down this way. Okay, so I'm going to show you how to use it, okay? Because I want you guys to truly understand this function. This is an absolutely important function. You cannot avoid it. You're going to have to deal with it in calculus classes, throughout calculus classes, okay? So when the input is -3, right, the absolute value of a negative number, so this branch, we're not going to be using that branch, right? It's going to be, because the input is -3, so this is going to be -3, right? Negative and -3 is what? Is a +3. See how that's being used? And of course, you can just go for it, right? The absolute value of -2, the absolute value of -2 is 2. The absolute value of -1 is 1. So we got 3 points here. We got 3 points here. Input a -3, output 3. Input a -2, output 2. Input a -1, output 1. For 0, when input is 0, the output is 0. And we got 0, 0. And for 1, 2, 3, that's straightforward, right? We can just use this branch, or you just, and this should be so easy for you, but don't forget how we have come along, okay? The absolute value of 1 is 1. The absolute value of 2 is 2. Okay, the absolute value of positive number is the same as the number. Okay, I want you guys to keep repeating those sentences. Those sentences will serve you well. Okay, and I promise you that when you're in calculus 2, you will still be using that. You will still need to use that sentence. Okay, the absolute value of a negative number is its opposite. So now we got lots of points, right? So let's plot these points. You may like to pause. You may like to pause. Okay, but I'm just going to go ahead to plot these points. I'm going to organize my rectangular system. And I know that it's not because the range, right? So I don't need much to be in the negative direction. And I will have, I'm going to use, say, -4 to +4. Okay. And here we go. So we have all these points. We're going to put the points in. I'm going to put the dot. Okay. -3, 3. Input, output. And next one. -2, input -2, output +2. Input -1, output 1. Input 0, output 0. Input 1, output 1. Input 2, output 2. Input 3, output 3. We can keep going. We could choose fraction, decimal, whatever you like to choose. Okay. And now it's time to connect the dots. It's time to connect the dots. So let's connect the dots. There we go. So that's the absolute value function. That's the absolute value function. Those pieces, you can see the range, right? It tells you the range. The range is greater than or equal to 0. So where do we get that? Well, this is a positive, and this is a positive, and that's the 0, 0, right? That's where the 0, that's a 0, 0. So as a picture shows you the range, okay? Above x-axis means positive. On the x-axis means the output is 0. So that's the absolute value function and domain and range. Okay. The most difficult part, if we look back, the most difficult part is actually understanding the sentences and be able to use it So here I'm going to give you some examples as, by the way, this function is called a piecewise function. It's called piecewise function. There are two pieces, right? We have one function here, and it's branched out. There are two pieces. Okay. So that's the absolute value function. When we have covered all of these functions, and next, let's do a summary. Okay, let's do a summary. So far, how many functions have we had? Okay, so let me save this. I'm going to bring back the other functions. ABS function. Okay, so what I'm going to bring back, I'm going to bring back the other functions that we have done, and we put together and we summarize. Okay, we summarize them. We put them together and summarize. I think I didn't put it in this file, in this, oh, one-to-one function. One-to-one function is something we're going to cover next week. Okay, so far, we have all these functions. Okay, we have all these functions right here. There. Okay, so I'm going to bring them all together. All of these. Okay, we did before. Right? And summarize. And there are a few more functions. Wait. Okay. And over here, right, these functions. Okay. There. And one more. This function. Whoopsie. Wait a second. Okay, so I'm summarizing this. Okay, I want you guys to also find your stuff. Okay, find your stuff. Summarize it. Take notes. So we should have a good summary here. All right. And one more picture for 1 over x. 1 over x. Okay, that curve is very important over here. So we did those before. And I'm going to put it right here. Right, so all of these are the functions we've done before, right? Throughout in this first week of the semester. And we have a constant function, this function, f of x equals to x to the power 3, x, cubic root. Okay, and the square function, root function, and we also have this reciprocal function, right? And now I'm going to insert the absolute value function somewhere here. I'm going to put it right next to x squared. Okay, I want you to think about, why do I do that? Why do I do that? Wait, what did I do? Did I, hold on. Did I delete something by accident? I think I did. I think I deleted something by accident. The square root function. I deleted the square root function. Hold on, that's not a big deal, okay? I'm gonna go back to grab my square root function. Okay, the square root function. So I'm just going to bring them all together. Okay, the square root function. Just put it here, okay? And over here, I'm going to insert a column. And this column, in this column, I'm going to put my absolute value function. So what I'm showing you is that when it's very important to summarize, okay, input, okay, the rule of the function, right? It produces the absolute value and the graph. Okay, so I'm going to bring the graph with us. Many of you know the V shape, but you must do it by yourself, right? So that V shape. And I want you to think about why I put these three together, right? Domain and range. We just talked about the domain and range. In fact, the square function and absolute value function, they have the same domain and range. They have the same domain and range. Okay, so last, of course, is the reciprocal function. So here we are. We have all 8 functions covered from the basic function that we have discussed this week. Okay, the first week we have accomplished quite a bit. And next week, we will continue the journey but those the remaining functions are going to be more complicated. There will be more complications about the rules, okay? So here's the summary of all the functions, and you will have, quizzes based, asking about these questions, right? Asking about, matching the curve with the function and so on and so forth. But anyway, we have covered absolute value function here, okay? And I will talk to you in the next episode. And if you have any questions, okay, please let me know. The absolute value function, regarding absolute value function, the homework will be assigned next week. But I urge you guys to study this material. Okay, the homework will be about absolute value will be assigned next week. And so this week, just to, but you need to get started on absolute value function. This is a very, very important function. And you cannot make it without dealing with this function in your calculus class. So please get started on studying absolute value function and all of these 8 functions. Okay, we have next week we will study the exponential function, the logarithm function, and the following week and the week after we'll be studying the trig functions. So we're going to study each one of those basic functions, and we're going to work hard. Okay, just remember, this is 5 courses in one. You have to work very hard. If you have any questions, please reach out to me, and I'm looking forward to work with you. And thank you for watching.